Yeah, started. Yeah, go ahead.
Yeah. So, okay, first problem is combination. So our first problem is combination two. So we are given a collection of candidate numbers. I mean, list of array of numbers are given, and some target is given, and we have to find all the unique combinations in the candidate, where the candidate number will sum up to a given target. And each number in the candidate can be used only once in the combination, and it shouldn't contain any duplicate combinations. So here your target is it. So these are those possible combinations which will sum up to 8. For 5 again this, and coming to the constraint, target will be up to 30 and our candidate length is 100 and array element can go up to 50. Yeah. So what should we put here?
So we had a similar problem earlier, combination sum one, right?
Yeah.
So
Only, yeah,
what
go
was
ahead.
the difference between both of them?
Their duplicate is not allowed, and secondly you can use number any number of times, and here you can use number only once.
Okay, and that the duplicate is not allowed, but here also duplicate not allowed, right?
Yeah, but there you can use, like, if you have to get 8 and if there is you can use 4 times 2 also, that will work in previous one, but here you can't use 2 4 times,
Okay.
only it has to be one.
Okay, so you can use any number in the candidate n number of times, right? In
Yeah,
the
if
previous one, yeah. Okay, and in this case you cannot. But you, but then duplicates are not allowed there. That is what also it says, right? So
yeah, I
combination
think
should not be duplicate. Okay.
we can have duplicates in first one, right? I think
Yeah, yeah, you're right.
yeah, yeah, okay, then here not allowed. Two things are different, so it should be number should be used only once and duplicates are not allowed here.
No, you cannot have duplicates there, but you can use one element multiple times.
So
Okay.
duplicate combination is not allowed, right? Okay.
Yeah,
Okay.
yeah,
Hmm. Okay. So that
and
is same for both, but
yeah,
only duplicates allowed there, and here duplicates are not allowed.
yeah. It's like knapsack only where in the combination sum one we have infinite supply. Uh, like the
Hmm.
coin change problem, we have infinite supply of the coins. Here, it's not like that. We have limited supply. The way it's given in the given array.
Yeah.
So that we can do with knapsack also, right? And
Yeah.
backtracking both. Okay. Hmm. Okay. Yeah. So sorry to just go in a different direction. So talking about the sum. So what would be a brute force? A very quick way.
Quick way, like generate all the possible subsets and check uh, whether it forms a target or not, right?
Okay.
Hmm.
So it will be still like a knapsack way, right? 2 raised to n.
Yeah, either you can take or you not, or you don't.
Right, because you cannot do using iteration, right? Maybe possible, but you'll have to use a bottom-up approach, right? Okay.
Yeah.
Mhm.
So will sorting help?
Yeah, sorting will help because duplicates will avoid. I mean, yeah,
Hmm. Yeah. And then we can decide also, no, that
whether,
whether to
yeah,
move
whether
ahead
to
or not.
not depending on the previous one. Yes, yeah, that's it.
Okay, so in this, we need to sort the array, input array, so we can have a control on the uh, duplicate candidate, right? Okay, but there you don't need to sort. Okay, and because of that, you can actually stop using the same number again and again.
Again, yeah,
Santosh, I think we are not even having duplicates here. The array would be all unique elements. In the previous question, we had the liberty of choosing one element multiple times, but
Mhm.
here we just have what the array is. We can only go by the array.
Right, right. So yeah, so whenever there is duplicate, in the sense we have in this example one candidates, we have two ones, right? So they are still duplicate numbers, but they are at different indexes,
Yeah, that's
right?
right.
So we can still
Right.
use them. Okay, okay, okay. So this is also I think we have this is the second time it's seeing being shown here, right? I think
Which
so.
one?
The combination sum two or no?
Yeah.
It is the first time
Mhm.
coming here, or did we
No,
attempt it
we have
earlier?
earlier also combination sum one we have done.
Okay,
I don't, but in some session we have done.
okay,
Not maybe not here. Yeah.
okay, no problem. So you said like we'll go duplicate, right? Sorry, a sorting way, and then we actually do a similar to similar
Backtracking.
backtracking. Okay.
Yeah.
Okay, so I mean, why backtracking? Why not simple DP would work here?
DP you don't need to in DP you'll have to cache, right?
Hmm.
Size is not that big, so I don't think so.
No, not about the size. What he's asking is, see, DP property either it
I mean,
has a
what is the intuition for backtracking? I mean, that I couldn't figure out.
Backtracking is, let's say you have to get a sum of it, right? So what you'll do initially, you'll start from here. You have array of numbers. Let's say you took first number as 10,
Hmm.
and your target is what, -2. So definitely this is not a valid number to take, right? So you'll
Yeah.
backtrack from here. Then you will take 1, and your sum is going to be 7. So further you can proceed from here. You can
No,
get
but sorry
yeah.
to interrupt, but this is not backtracking, right? This is normal recursion. Or am I missing something?
This is backtracking
Because
only, right?
but what do you? What is the undo step?
so undo
Undo
step
is
is when the target isn't reached, right?
yeah, negative when either you reach the target you return, or when you get something negative. So that part was not valid for us. So you'll backtrack from here. I mean, you will undo that part, right?
Okay, but the way we do in the knapsack, like if the current weight is greater than the weight value, we don't take that weight, right?
Yeah.
Here also
So
we'll have to do, right?
similar to that, if I go on the same lines, I don't take this 10 because it's greater than
Mm-hmm.
8.
Yeah.
So
Eight.
and
Yeah.
then just like just two calls, one for taking 10 and the other for not taking 10.
Mm-hmm.
So will that not be enough? I mean, backtracking, is it being overused or something?
Well, see, the DP
I mean,
problem
I'm
will be only if there is a sub problem, overlapping sub problem, right?
Yeah. That's
So
also.
because the way I'm thinking, because we have to still reach a target, right? So for the DP, if we are in the recursion stack, so in a state, so do we have to take the target also into consideration? Yeah, that might be a possible way of doing it. Yeah. So, but do we still see overlapping?
yeah. I mean,
Where?
yeah.
I think so. Yeah. I think then yeah, it might be possible both ways. But the only thing is the duplicate thing. What we are discussing about, how to avoid that. So that might be a challenge in knapsack, right?
Yeah.
Other than that, it might be
Where's the
possible.
duplicate?
Duplicate in
Pardon?
the sense n number of times the same component if we take, in the case like if we have a 1 and if we keep on using the same element 1 1 1 8 times, right? So that duplicate we want to avoid, right? I don't know, like Harshit, do you have something, did you do that using a knapsack and also avoided the duplicates? Was that
No, no, I'm planning to solve this. I have not solved it yet. But I think I mean, duplicate is something we need to take care. So that has to be
Sorting
taken.
is must.
but okay, even in that case, if we want to take care of duplicates, how do we take care, like the knapsack way?
Yeah.
um,
So,
So maybe we look at the index where we are coming from, and we still have a sorted array, right? So
mhm.
whenever we go to same way what we do here, right? Whenever we look for the index where what we are coming from, and if we look for the next index, okay, and then we compare the previous index, okay, if they are same, okay, then we just can not include that also. The way we are
But why? I
exploring into the
mean, we
greater
can
than.
include that, right? I mean, there would be a call when I'll have 1 comma 1 in my recursion tree.
Yeah, 1 comma 1 you can include. Uh,
Mhm.
um, so then how do we stop this, right?
Because I don't think we need to worry because we can consider them as two different elements of the array, right? So in one call you take this second one, in the other call you skip it. So that way I'm thinking. I mean, like normal recursion.
But then if you skip in one call and then you take in the other, but still you have both the calls, no? So how do you differentiate that? So somewhere you will have to stop that duplication, right? Okay. Now that would be interesting to think about. Candidate I. So where here we are just looking at the one which is closest to it is a duplicate or not, right? Huh.
Yeah, the previous one, what you have used, you'll compare num of I and num of I minus 1. If they are equal, then you can skip, right?
So you pick one index at a time. It duplicate in term of index, right? We cannot use the same index twice,
Yeah,
right?
in terms of
So
index only.
yeah, so if we use one index at a time, and then next time we don't use that index again, then there shouldn't be duplicate.
Yeah, we
Yeah.
would never be using the index again if I go by the knapsack way because we'll always be moving ahead, right? We're not doing it like infinite coin supply. So I don't think we'll be reusing any index.
So you are treating it like a subset sum problem, right?
And that coin change problem.
Your coin change. Okay. But in coin change, you are given option to use a coin ample amount of times, right?
Yeah, that's what I'm saying. So combination sum one is that way. Here the difference is that you just have to use the coin as per the
Only
given
one.
array.
Okay. Yeah. I mean, whatever number of times it is present.
Yeah.
So
But
you don't
in
need
that
to
case, how do
sort
you
the
avoid the
index.
duplicates?
Hmm.
Why avoid the duplicates?
So sorting will be required, Leon, because if you want to look for the duplicates, in the sense, even if they are at different indexes, right?
No, like yeah, but we I think it yeah because we distinguish it by the index. So sorting or not sorting doesn't matter. Right? We
No.
don't need to do the sorting. Like in the coin change, we don't do the sorting.
Hmm.
Right? We just pick index 0 and index 1 and 2 and see,
But
we either exclude or include it to get to the target.
there
Hmm.
you cache the values, right?
So Santosh, do you mean this by a duplicate like this triplet and this triplet? So
Yeah. This is
this is this the duplicate you are referring to?
yes. This is a duplicate.
Yeah.
Okay.
So
So,
I think
but
like
that is
two
because
step.
of non-sorting, right? Hmm.
Mm,
In solution set, you can't have these two. Only one you'll have.
yeah, that's what I'm saying. You cannot have these two. But I'm trying to see when will I take this? Like when will be this taken inside? Because as Leon said, if I go the normal way, I don't think we'll like I'll take this part, okay, but I will not bump onto this one 762 because two is to the left.
Yeah, you will never come again to. I mean, in the next iteration,
Yeah.
because
That
once you
Okay.
will
have
not happen. I
Okay.
don't think so. That's
Okay.
one duplicate way, right? So
Okay.
duplicate
I see.
combination will be something different, right?
We can get that, Shashank. Let's say we
yeah,
have another two here. Okay.
yeah.
Somewhere ahead.
I mean, in the array, if you have two, then that works. But if you have only one, two, then you can never get that previous two again in the future iterations.
Yeah.
Yeah,
But that is where sorting is helping, no? Uh,
yeah. Two similar numbers will come adjacent, and you
yeah.
can
So
avoid
if
at
I
that.
don't sort, and if this is my array 10, 1, 2, 7, 6, 1, 5, 2, I will get this triplet 276 corresponding to these three, and I
Yeah.
would get another triplet 762 corresponding to this 76 and 2. So this is a duplicate, right?
Yeah.
So we need to sort.
Yeah.
No, not duplicate, because the 762, the second two are different index.
No, but that 7 and 6 are repeating,
No,
right?
but that's what the question is saying. No, the combination has to be unique.
Yeah, so there are two things. One is the combinations to be unique, right? And using the same number over and over again in the
Sorry.
same of the same indexes, right?
Yeah.
Yeah,
Yeah.
But in the
this is
knapsack
why we
way, how
sort.
we will avoid this? If we are not, if we sort it, then it will be possible, right?
Yeah,
Yeah, yeah.
sorting
So
is,
yeah, sorting is needed.
Okay, we'll need sorting both in knapsack as well as the backtracking.
Knapsack.
but what is overlapping is a problem here? I mean, like, is it reducing the, I mean, let's say
Uh,
you reach to,
Yeah, because see, whenever you are going in a tree, right?
yeah,
Some point of the time, okay, so you are not using any duplicates, so then how you need that? Why not? See, because see, here you see 1 1, you are using 1 at least at 1 1 1 6, and you are using 1 in 1 2 5 also. So there might be different combinations, okay, for the index 1 and 2 being used for multiple combinations, right?
yeah.
So for that
Oh,
you can have a sub problem, overlapping sub problem. I think so. It should be
I,
it should be fine.
yeah.
If you
But
go the question stack and if you have a very big test case,
if
I'm thinking, Lord, yeah, maybe if you think so, it's not possible, then you can.
I think it it is big. No, let take another example I did. You have another one after 5. Okay. If you have another
Okay.
one after 5, then what would be, you would have that if you have like 161 and 611 again, that is not duplicate.
No, but 6 you are using 2 times, right?
But
Yeah.
the combination of that triplet are different, right? They have to
Mm.
they have different index. Otherwise, you will ignore the last one.
Mm,
So you're saying 1 1 6 one combination, other combination 6 1 1, right?
Yeah, but the input, you have an extra one, right? One
Yeah,
after 5.
3 1s, yes.
If we only pick like 116, we ignore the last one.
but okay, so in that case,
Do
you are
do
saying
we
it will
did
be a
the
duplicate.
test case and see if it print
Okay,
out?
let me try. Okay, so but with just one, or I think we'll need, yeah. So 1 1 6 will always be only once, but I don't think so. You can have more than once, right? Correct.
Yeah.
Yeah. So if even if you keep on adding one many number of times, so 1 1 6 combination will come only once.
Oh, hmm.
Is it me?
Okay.
Okay. Okay. So okay, let's go ahead with our implementation then. So, but then we'll have to try out the knapsack way also, right?
Yeah.
Okay. Yeah. So, but is it clear, Harshit? Do you want to say anything about what Leon was saying?
Mm, no, not really. So
Oh,
I second that we would need to sort and to avoid this duplicate thing.
yeah, but because if we keep on adding 1 1 1, the way Leon was saying, right? So, we should actually get two outputs of 1 1 6 at least, right? because we'll have one of different indexes. So that is not the case. Maybe if
But
I add one
that
more,
would be a
say,
permutation, right? Those are two different
yeah,
permutations.
yeah, yeah,
But if you consider them as combinations, they are just one
one
combination.
combination. Yeah.
So that is what the question says. They must not contain duplicate combinations.
Yeah. So that is helping
Then,
because of the sorting, and then we compare them in the
then in that
recursion
case, it
kind.
does not look like a coin change, right? Because we could, or we could,
No,
yeah, we
coin
have
change is also.
many one, but we pick only two of them.
So for the coin change, if my sum is 7 and I have my array is 3 comma 4, what would be the answer? 1, right?
Array is 3, 4 and your sum is 7.
Yeah.
Then
Yeah.
only
So
one is
answer would be 1.
3,
I have one way of obtaining this sum, right? Which is just take these two elements, right?
3, 4. Yes, yes.
So we are saying 3, 4 or 4, 3. That is the same, right?
Yeah,
Yeah.
one and
Yeah.
yeah. Otherwise, it will become 2. I mean, if we take that way,
Mhm.
4
So
also.
if we had 3, 4, 4, in that case, then we just have 3, 4, 1 combination. That's all right.
Then we have this. Just sorry, come again. You're saying 3, 4, 4, right?
Yeah, just 3, 4, 4.
Yeah. Then also 1, because this can go either with this or with this.
Hmm.
Let's try. I think in console, it should be 1 only.
Yeah.
Mm.
Yeah, it will be 1.
Yeah,
So
this is a
because,
tricky concept. This
Yeah.
you take this question, then you take that question, staircase question. So we have n, and we have to find a number of ways. So in that case, if my n is 7, okay, and if I take 3 steps 1 and 4 step 1 at once, so this is one answer. And if I take 4 steps and then 3 steps, then this is another answer, because here the arrangement is important.
yeah, that the number
Like
of ways
I
is
was reading a
different there.
blog on this thing.
Mhm. Yeah. So in this case, when you come to 3, so you will be there, and then you'll find 4. You're done. Then you come back again. You look for the second 4.
Yeah,
But you look for the second 4, but it is a combination of
because
first 4.
we'll make two calls. Like our recursion would be this,
Yeah. So that will be pruned.
and that plus would be, and
Yeah. So you won't get the
yeah, and
next
this
4. Yeah.
another call.
Yeah.
Yeah,
So that won't be there. But then if you come to, you have 3, and then you cannot skip this 4 at all, right? You'll have to go in the for loop. Okay. But I wonder if the knapsack way will actually prevent that. Okay.
Without sorting, I don't think so. Right.
Okay. Let's try that. Okay. Maybe. Okay. If we get time after this session, we can actually do a quick run over here.
Yeah.
Okay. So yeah, do you want to go through the code? And
Mine is like that way. I mean, backtrack way only.
Mhm.
So what I'm doing, I'm just creating a backtrack function, and I'm sorting the, what do you say, this array,
Mhm.
whatever target is there that I'm giving, and the
Mhm.
starting index. This is the which will store the intermediate results. This one,
Mhm.
like 116 something, and this is your final address.
Okay.
So it will go here, and this is my that condition. What do you say? Terminating condition. If my target goes negative,
Mhm.
and inside that I'll check if it is equal to 0, then I can take that, right?
Yep, that's fine.
Yeah, and we can return from here. Otherwise, we are just running a for loop from
Mhm.
start to the end of your nums. And
Mhm.
if I is greater than start and nums of I and I minus 1 both are equal, and this is the point where we avoid the duplicates.
Mhm.
We'll continue. Otherwise, whenever I took that particular num, I'll subtract it from my target. I mean, target will keep on decreasing because I consume that much part. this is like I plus 1 for the next index I'm going. And this is the temporary array to which I'm appending the number which I have subtracted here. And this is the rest. So this will call itself. I mean, for the next call, these are the parameters that I'm passing.
Okay, so in the case of 344, if we just go, so
Yeah.
if you come on line 12, we already have 3 in that case. And if we are on the second mm, iteration stack, second recursive stack,
Yeah.
okay, so at that time we are at 4, if we just assume that we are midway there. So we'll
Yeah.
take the first 4, go in this for loop, okay. Then on line 13, it's not the condition not satisfied. You come here, you go to this backtrack. Okay, you complete this, you get a result, you come back again. Okay, then you actually undo your first 4, right? Then you come in the for loop, and then you check this condition on 13, and the second 4 won't be considered, right?
Yeah.
So this is actually trying to avoid the duplicate combinations, correct?
Yes. Yeah.
Okay. Even
Uh,
even if we have 4 at 2 different indexes, so the combination is still same.
Because once we sort it, the things will be, what do you say? Array will, the similar numbers will be closer to each other, right?
Yeah.
So we can
wouldn't the
check.
line
Yeah.
13 skip the second one
Yeah.
for the example one? We have 116, right?
Mm-hmm.
Yeah.
So
So
how
okay.
would that 116 end up in our result?
Okay. Because for the first recursion stack, you'll have 1. Okay. Then it will go in. So you started with 1 in that case. Your I was
Yeah.
at location 0. Then you go into a second recursion stack, right? So at that time, your I is actually at whatever that location is, start location. So you actually don't compare the equalities when you are at the very initial, at the start positions. You see the line 13, right? If I is greater than start, that is
Then
very
only.
important here. Along with looking for the
Okay.
duplicates, because if you are starting at the same index, then you allow.
No, but okay, initially that's a for loop on line 12 with a for loop, right? So first I equals 0 will be 1, right?
Okay.
Then I equal 1, right? That would be 1 again. Then wouldn't that, when it see line 13 that I equal 1, so I greater than start, right? So 1 greater
No.
than 0.
So start
No,
will
no,
be
no.
1 at that time, right?
Yeah. And I is also 1.
So
I'm
start will
talking
be
about when I equal initially, when start equals 0, right? So I equals 0 first. We're done with that recursive call. Then I will be equal 1.
So
Okay.
your start also will be 1. So you won't
Mhm.
consider that. Yeah.
Okay. Okay. Yeah.
Okay. Yeah. So this is a small trick, right? Make the array sorted input array and then use this on the line 13, which is very important. And that is what we don't do in the combination sum 1 problem, correct?
Yeah.
Sorting and this one, both of them.
Even
Yeah,
for, I mean, yeah, go ahead.
sorry, one quick question. Like for the recursive call, when we do come back to the second one will have the start of, like in this case, whatever
It'll
the
be 1.
second index of 1, right? Then how is it skipping it? That part I didn't get. So
Your
the
I
fourth,
is also 1, right? And start is also 1. 1 is not greater than 1. So it will not check that condition.
okay, so let me just say, so we have
Let's analyze
1 1, yeah.
that will be better then. So initially, what I mean, your array will be sorted 1 1 2 6. Let's take till here only. So
Yeah,
initially your start is 0, right? And I
yeah,
is also 0. So you, for the next call, what it will pass, I will become 1, and your this start will be updated to 1 only, and start will come here 1, right?
yeah.
Now I is what? I will also be 1 because I'm starting from here to here, and 1 is not greater than 1, right? So it will not check. I mean, nums of these two, it will not check here.
Yes, so for the recursive call, it will add the second one, isn't it?
Second one, yes, it will add this.
Okay, okay. Okay, for the first one, it will, okay, continue. Okay, got it.
Hmm.
Yeah, it's the small trick here. So
Yeah,
at least for this combination sum 2 problem, if we have the input sorted and if we use this condition, at least the backtracking works. Okay.
Yeah.
But the way Harshit saying, we will try after the session if we can do a knapsack way also.
Yeah. One
Okay.
more thing. Right?
Uh-huh.
So when is this being triggered? Line number 13.
13 will be triggered. Let's say I have one more one here, right? Three ones are here, right?
Mm-hmm.
Yeah.
Mm, then also it will
Because,
not be triggered, right?
because right now we discussed when I was equal to start, right?
So
Yeah.
see, every time when we are in a recursion stack, okay, and we have many number of duplicates, so it will take only single one, then it will pass on to the next iteration and next recursion. Correct. So there you can take as long as you are able to satisfy it.
Yeah, yeah. I understand when we are why and how we are taking it. I
Mhm.
just want to see a case when we are ignoring, like when we are executing this if on line number 13.
Yeah, because when yeah, so yeah, Anwar has given that test case. Okay, so in the case like if we are done with the for loop, right? When we backtrack again, if we have
Mm-hmm.
one, right? So the second one we don't take no. If we are
Oh,
backtracking,
okay.
we come in the for loop over and over again. So we don't take one at all. That's the only one once we take in that particular recursion level.
Right, right. For that level.
Yeah.
Yeah.
So that avoids all the duplicates combination.
Mm-hmm. Yeah.
But where do we skip then? Let's say we have multiple one, but we only need two one and
So then,
six.
so then every time you have to have one at different recursion levels, right? But in the same recursion level, you cannot have the same number over and over
Oh,
again.
okay. So
So
we
that
can,
avoids the duplicate combination.
Yeah. So this is there's nowhere you're doing that two calls, right? Like picking and skipping.
No,
Mm,
yeah, that is what I was thinking. How can we actually get that in the knapsack way,
Mm-hmm.
So, so therefore, this for loop helps here, because most of the
Yeah,
time
yeah.
they have
Right.
either you do a knapsack way because most combination one will surely work, in the knapsack way. But I doubt how we can actually avoid this condition in the combination sum 2 problem.
Right. And the other blocker I see using that DP ways here, I mean, how do we cache? Because the answer is a vector, right?
yeah.
So, I mean, caching would be difficult.
Then
Yeah,
dictionary.
we can cache based on the target and the start, right? And maybe because the target will be always different, no? Every recursion call will have a different target, right? And the start will also be different. So based on that, maybe possible because I think if we have to do the combination sum one problem using the knapsack way, and then we'll have to do memoization. I'm not sure whether we need it also. Then at least we'll have to do a caching there, no?
Yeah,
So
yeah,
how
but
will it
Yeah.
you cannot use just the target as your DP state. You'll have to use the array also.
Yes, target should not be enough because we know where we are, no?
Mm,
Because array is actually so at the end the target. Okay, you mean to say if you have some number, then the target comes to the same value. But in that case, the index will be different. Then the start value will be different or
yeah,
not.
so I'm saying
Hmm.
like two different targets can have the same array.
I think two different.
Because that is why we take the DP states as the target and the array size, right? Because they only uniquely determine our like every
yeah,
call.
yeah, yeah. I agree with that. Yeah, the index and the target, those two will be there. Yeah,
So we'll have to take just the index and the target, no?
yeah,
So
Yeah,
we
yeah.
cannot take the array. So if you want to take the
Okay.
target size, so our array size,
Okay, okay. I got what you're saying.
yeah,
Okay.
the start will actually help. I think so, maybe.
Yeah, yeah, yeah. Yeah. I think I took the discussion somewhere else. Okay.
No problem. Okay, so we'll try that later. Yeah, I think this is okay, right, Shashank?
Yeah.
Okay, let's move on to the next one.
So in this case, one thing, in this case, we can see that in this case we only need 2 1, right? But if we have multiple 1 in there, is there a way that we can trim the those so that
You
it could run faster?
you can use a map or two variables you can use, and directly you can, whenever you see that there are stream of ones, then directly you update it, right? I mean, to the next pointer you take the immediate the last previous pointer which you have seen, like in the repeating characters we do you see longest repeating character in a stream of that, so at every index you store which character is present, so rather than going single you can directly make a big leap
Yeah,
by
it would
advancing.
be hard because it not only depend on that, but it also depend on the
Other
value, input value in the array. Yeah,
mm,
but it
yeah,
seems like if we have a lot of 1, then we keep do backtrack like this. It's gonna take a long time, right?
yeah.
Okay. Yeah.
How will you avoid then? Because we have used this concept there, avoiding a stream of similar characters. But here, I don't know. Like,
Yeah, I think so. This is very important, right? Sorting and then this 13 line. That is the
yeah,
only way you can actually avoid the duplicate combinations.
and
So even
for
as
five,
Leon was saying, if you have more number of ones, we still don't have two such combinations, right? You cannot have that.
no, we'll have
And that takes
one
care very well with this trick.
13.
Right. It take care of it, but it still look through the unnecessary one, right? Then
Yeah,
what I'm saying. If we can trim that, that would be.
Well, that is what the pruning is here on line 13, right? So exactly it's doing it. So anyway, you
no,
have an array, you'll have to still traverse it, right? You cannot just
he-
overlook that array.
yeah, he's trying to
But
skip like if
yeah,
one
but
one.
yeah. So you are avoiding your recursion stack altogether, and that is huge saving.
Yeah, more than that, I mean,
Yeah.
it will.
Don't you feel so, Leon? See,
Mhm.
it doesn't go to line 15 at all. It will skip on line 13 and 14, and it's just reiterating through the whole array, which anyway it has to do. Whatever the input will be, you'll have to go through. You cannot avoid that, right?
Yeah.
But that is just indexing. It's an array. It will just keep on indexing O of 1 for every call.
Yeah. Okay.
Okay, yeah. Let's.
And for all the like next permutation, permutation one, permutation two, permutation three, all these are based on same. I mean, same template, right?
Mhm. Maybe we
Yeah.
should take all of this together in one of
One
our
day, yeah,
Tuesday session, right? Yeah. Okay.
yeah, yeah. So that it will form a, what you
Yeah,
said.
we need to understand the differentiation. It's very important. Absolutely.
Yeah,
Yeah,
it's
and
very
we can
Yeah.
compare and contrast and understand it. Yeah.
Yeah. Even permutation and combination, both of them together.
as important as
We take
solving new is like revising these concepts.
Yeah, because this is the basic, right? If we just falter on that, that's going to be a problem. We need to know this at all. Okay, let's go to the next one.
We'll take one session whenever. Okay.
Yeah, sure.
Yeah. So this
Uh,
is like we have two. It's not moving.
Okay, so this is a count number with unique digits, right?
Yeah.
And then we are given non-negative integer and count all numbers with unique digits. So n will be the power, no?
Power.
Power
Yeah.
of 10. Okay.
So if it
Okay.
is two, so it's
Mhm.
0 to 100.
Yeah. So before going in this also, let me ask Harshit. Harshit, is it possible for this to solve
Is it?
using digit DP?
Count number using unique digits. Mm, okay. Count all number. So we are given
Slightly,
n, right?
uh-huh. And n is the power of 10.
Should be
Okay.
right.
I mean, I have the range.
If I may say, this one has 959 downvotes and only 504 upvotes. Why is that?
That is deceptive.
Mm. Yeah, it's like
Oh,
people find it too hard to
Is it?
follow. Yeah,
oh,
sometimes.
I thought from where that number came. Okay. Yeah.
Okay.
Okay.
Yeah, that's okay. Yeah, but yeah, just before even we go in this, I think so. It won't be possible, right? Okay.
Yeah, because we do have a recursive substructure, right? We
Okay.
can use the position
Uh-huh.
to okay, annotate.
Mm-hmm.
Let's say these are the 4 digits. uh, I can identify the number till like how many unique digits I can form using these three, and then I can append suitably something here. I mean, at first it looks possible.
Is it because that there is no use of that tight or reserve, whatever you call it, right?
Restriction.
Restriction, yeah.
It should
Yeah,
be
yeah.
right. You should cross 2
So if
digits.
we had something like this, if the number was given instead of a power n, right, then it would be possible, no?
Okay, we can use that, no? So let's say, so basically what Roger used to do is he used to form the numbers. So let's say I put 1 here, okay? Then I cannot use 1 in the digits coming ahead because I want unique digits.
Uh-huh.
So that way we can restrict. Uh, like if I put a 1 here, I start my like a parent call, and I start making my number. So if I put a 1 here, so in the digits ahead, I cannot use a 1. So that way I can percolate my restriction.
And secondly, since it is only up to 100, so your first digit shouldn't be more than 1, right?
Mm,
Because you can't cross 100, right? 0 to 100 you have to. So tight variable should be there for checking what should be your first number at first place. Either
But
0 or 1.
but
You
he's
can't go
saying
more.
he can use that for the uniqueness, no?
So in this example, wouldn't the answer be 19? Am I getting that wrong? Because if you put 1 in the first place, then the only possibility is to put 9 in the second place, right? To
No,
add up to 2. Is that correct?
no, actually, what it says is if you are given an input 2, right?
Yeah.
So you need to find all the non-negative integers which have unique digits, right? So how many unique digits you can form? So if you look at the explanation, sorry, actually went to a different direction. So let's actually come to the basic thing. So if you look at the explanation, what it says is these 11, 22, 33, 44, these are not unique ones, right? So you
Yeah,
have a
because there
repetition
are
of 1, 1. Yeah. So if
two
if
of the
it,
same digits, right?
correct. So if
So
we go from 0 to 100, and we don't have to take 100, so 0 to 99, right? So you if you avoid these 9 combinations, so your answer will be 91, correct?
Yeah.
yeah,
Did you follow?
wait, am I getting this wrong? So what we are doing is
I think her process is also correct only, right?
input says 2. That means the size is 2. Or the
Yeah.
addition of the 2 digits should become 2. Oh, no. I get.
No, not addition. Actually, it's a 2-digit number, right? So from 0 to
No, I
99.
understand. So
Yeah.
basically they're saying how many unique digits can be 2-digit unique numbers being used to make up from 0 to 99. So then 0 to 9 would not be used. 0 would not be used in the first place.
Not
Right,
only
because
the
that's kind of
2-digit number,
redundant,
even you
right?
can
So it
count
has to
that
be
1
1.
digit as well.
Oh, okay.
So this input 2 is actually give you the boundary of that. What is your range of those number? So range will be 0 to 10 to the power 9. So the last number should be less than 100.
Would be 100. I mean,
Yeah,
99.
if you put here 10
Not
to the
99,
power 2,
98.
so which will become 100.
Right. So so meaning less than that, meaning 99. But 99 can't be used. So the last number to be used would be 98.
No, 99 you
Right?
can use.
But doesn't it say that those numbers 11, 22, 33, 44 can be used, 99 can't be used because it's not unique
It's not unique. That's why you cannot use
digits, right?
99.
9 and 9 are the same.
Yes.
Yeah, that's why you
Right,
cannot
right.
use. But your range is
Yeah.
0 to 100, less
Right,
than 100.
right. Got it.
Okay.
Got
Yeah,
it.
that's good.
Okay.
Yeah,
So 98 is the last number that can be used.
correct. Yeah.
Right.
Yeah. So yeah, thanks, Praveen, stepping up. Yeah. So then how do we go about it?
So digit DP, what we are discussing, there
Okay, I
also
think let's keep that aside because that will be more complex, right? Okay.
oh, yeah. Okay.
You want to say something about it?
No, I was just thinking. I'm saying since your number should be 100 only, right? So in digit DP, we have a tight variable whether it should be allowed or not allowed. So whenever you come at the first place, only either you can have 0 or you can't have 1 also, right? Because if you have 1, the next number you can't take anything. Like
So Harsh's
no,
argument
no,
was like you can actually use this one, right? That will be a restriction, right? So
yeah,
at the other places you can look if this is one is coming up, then you just skip that number.
number, yeah.
Yeah. So maybe yeah, we'll
We'll
discuss
have
that
to use
later.
tight variable, yeah.
Yeah, I think so. There might be some test case for it. Okay. So let's actually do this the basic way.
Yeah.
Okay. So how do we proceed in this? So actually the brute force will be just go through the numbers, right, from 0 to 99. Yeah, and then look for the combinations. If they have the same combination, just ignore them and then keep on counting. Okay, but that is one way of actually it will be a good way in case if you have to return all the numbers, right? So that will be an optimized way,
Oh, yeah, every number.
right? So there is no
Other
other
than
way you have to return all the numbers. So that is the only way. But now we just have to return the count, so we can do all the others optimizations. So we can find out, right, if it is a single digit, there won't be any duplicates. They
duplicates,
all
yeah.
will be
So,
unique. Yeah. So in that case, if we say it's 0 to 9, if we just ignore 0 for now, so 1 to 9 will be 9 combinations, right?
yeah, 9.
Mm-hmm. And then yeah, go ahead.
Sorry, zero should be included or not?
Yeah,
It should
we have to include, yeah. But if we
but
just yeah, anyway, we'll have to add one number always. So I'm just saying for the initial, if we just keep 0 aside, and if it's a single digit number, we can conclude that all the 9 numbers are unique, right? And if it's a 2-digit number, so in that case, it will be how much it will be.
Yeah, so
digit.
we go step by step, right? So if it's a two-digit number, then if I try to put one here, right, then I have 9 options here
Mm-hmm.
Yes,
from 0 to 9, excluding
1.
one, right?
Mm-hmm.
So
Mm-hmm.
this gives me 9 options.
Mm-hmm.
Similarly, for the rest, like I can put a 2 also, right? 2 till 9.
Mm-hmm.
So I'll have 9 numbers. So 9 into 9, right? So
Mm-hmm.
this is 81. And you just mentioned that from 0 to 9, we'll have 10 numbers.
Mm-hmm.
10
So
such, yes.
81 plus 9 gives 91.
Yeah, but that's a mathematical way, right?
Yeah, but I think we just
Algorithmically.
need, okay. Okay.
No, I was saying
But this
algorithmically.
this is almost a math problem, correct?
Yeah.
At least we have to come up with this uh,
The
this
permutation problem, yeah, what is mentioned, like number of digits to create, given that digit should not have, number should not have any unique digits.
mhm. Okay.
One way is backtracking also then, but that's very weird.
But then you will be forming the number, right? In that
Yeah, in
case.
that case, I'll be
But we
forming
don't
the
need to actually, we just need the count.
count only. Yes.
Hmm.
Okay.
So backtracking will be almost O of n, right? So this should not even go there that far, correct? Not
Backtracking
O
would
of n, it will be like a power of n, right?
Exponential, yeah.
Yeah. So what if we do the what Harshit did? What if we do for 3 digits? Maybe we can see a pattern.
okay.
Yeah.
So if we have 3 digits, then I'll have not I cannot put a 0, right? So I'll have 9 options here,
Yeah.
and for each of those 9 options, I would have 9 options here, right?
Yes.
I cannot include that number. Okay. Now I
Again,
am left with uh,
8.
8.
Is
8.
that the second one is 8? You have 8 option on the second.
No, no,
The
no.
second
0
You
you
to
have
can have
0,
0.
right?
So it's 0 also. Yeah. So
Oh,
Yeah.
yeah. Okay.
So first one you cannot have 0, therefore it will be only 9.
Mm.
Second one you can have 0, so it will be 9. But the third one you cannot have that number, both the
So,
numbers, right? So it will
Both
be 8.
numbers. 8.
No,
yeah.
this is only for he's forming a 3-digit. You have to form 2-digit also, right?
yeah,
So
we can
that is
sum it up then. We
81,
can add
Okay,
right?
it.
you have to
Yeah.
submit those two, this two, and then 1 digit plus 9.
Yeah.
Okay.
So
Yeah,
81
so for
into 8
3D.
is 648.
And then you'll have to add this 2-digit one.
Plus single digit
648
9.
plus 91. 539. Is that the answer for n equal to 3?
No, actually, okay. So it'll be 9 into 9 into 8 plus 9 into
It
9
is
plus 10, right?
739. So if n is equal to 3, it is 739 answer.
Yeah. So yeah, so what you did is right. So 998 for the 3-digit. So we'll have
Okay.
to do 99 for the 2-digit, and then you'll have to take 9 for single digit and plus 0, you'll have to add 1. Okay. So that we'll have to keep doing. And then if we go for 4-digit number, you'll follow exactly the same what you started with, 998, and then it will be 7, right? Because you are excluding the rest 4, rest 3. Same thing again, if you go ahead, then it will be 6, 5, 4, 3, 2, 1.
Yeah. I think it would have been more trickier had we be given a tighter bound. Like here it's pretty simple, right? We have to go, we know till how many digits we have to go,
Uh-huh.
because it's 1000 only,
Right.
always 1000.
Uh-huh.
So we know the number of digits. Like if the n is 2, then we know that we have to go for 1 digit and 2 digit, right? If n is 3, then we have to go for 1, 2, and 3 digits.
Yeah.
So had the number been somewhere intermediate, like 565, then we would have to be more careful.
So in that case, digit, so you'll still have to use this along with digit DP, right?
Yeah. Here there would be restrictions. Like if the number is like the upper limit is 500, then I cannot put a 6 at the hundreds place.
Yeah. So that will be more complex.
Yeah, that's what I'm saying.
So then digit DP will help in that case, but we'll still have to use this base.
Yeah.
Yeah.
So this is again like recursion only, right? Whatever you got the number for this, you multiply the count of k minus 1 because that digit you have used here, right? I mean, if it is any recursion function, you go for k minus 1.
Yeah, you can say that, but we can, because it's very simple, right? You know the number of digits, so you can just go and just subtract 1 from the n every time, right? And then get the answer.
Yeah, that iterative we are saying, right?
Yeah, iterative should be much easier. Yeah, you can have a recursive way also, but usually we avoid recursion as far as possible. If it is required, then only we try to use, right?
Yeah.
Because it might run into call stack issue. Yeah. Okay. So then how do we have, because it's exactly the way it is said, right? What Harshit was discussing.
Yeah.
So just keep on adding it. Okay. It
So
becomes
this
more
is what
simpler now.
I was going through the discussion only.
Mm-hmm.
So I'm just passing a count function, right?
Mm-hmm.
This is, I mean, 9 into whatever count I'm getting, to that I'm adding. This 10 is for the single, I mean, 0 to 9.
Okay. Yeah.
And this is for what you say, like for every k, it will go and calculate here and return the value to it, right? And how your k is going, it depends, like if whether it's a 1 digit or 2 digit or 3 digit, because every time you pass n, and 10 minus 9 will be 1. So whatever the max of k is, depending on that, it will give you the count.
Well,
K plus k is
so your line number 10, you are saying 9 into count of 9 plus 10.
yeah.
So where your count k, because if n, where your n comes in, because if your n is 2, how do you do that?
He has fixed, I think, yes, some right. Mhm.
Is it not, then you'll have to have it something different? Okay, this is some different way of implementation.
Yeah, I myself didn't get properly, but I think what
Yeah, because then
Harshit
in
was.
this case, you will always get the same number, right?
No, but you will subtract n here. No, 10 minus n always will happen. It will be 1 next time. Okay,
Oh,
it will,
you're having that n over there in the max. Okay, okay, I got it.
but still every time 9
I
only we
didn't.
are. No, no, recursively will decrease it. Okay. Yeah, go ahead.
No, I didn't get it. Like, how is he doing it?
This is 10 is for your single number, right? 0 to 9.
Mm-hmm.
And now you are
What if
passing
my
9. Go ahead.
no, go ahead.
Let's say n is equal to 2. I'm also trying to get, let's see. So
Mhm.
I pass 9 over here. I mean, this is my, what is a count function. So f of 9 I'm passing. Now your k will be what? 1, right? Initially,
Yeah.
whatever result you
One,
get.
yeah.
So k is 1, and since it is 1, is returning 0 for that.
No, your K is 9, right?
Yeah, but it will get subtracted there, right?
No,
10 minus 9.
You'll pass your K as 9,
Oh,
but this if condition won't be true. So
yeah,
you come down.
come down here. So this will be like k is again 9 only. K
9
is
into,
max of 10 minus 9, 10 minus n, comma 0.
but it won't be equal to k. So you are not going in that if loop, if condition. So you will come to line 7, right? So, so k will still be 9. 9 into 1 plus count of 8.
Okay, then again this will go like this.
Yeah, it'll keep going.
8 into 1 plus count of 7, right?
Yeah, 7 and all those things we need to keep
So till
counting.
with what extent will it go?
Till your k is not equal to
1?
whatever that 1. Yeah.
Yeah, 1. Okay. And then, yeah,
No, your N is 2, right? So it will go till
8.
8.
Sorry.
8.
Oh, yeah, yeah. Okay. Because your k will be, okay, k will
Yeah.
be some value, whatever it is, and it is okay. It's going to go to 8 only, and then it will return. Yeah, it's
Yeah.
slightly hard to understand, but if you have a iterative way, it's more easy. The way Harshit was saying, right? You
Yeah.
don't have to go this route, right?
And this 9 is for like whatever you are getting that digit, right? At that particular place. 9 times of it, right?
Mhm.
Yeah. So if your N is 1, you will return on the first call only.
9. Yeah. It's not intuitive. It looks like.
No problem. So just going now, but this is good implementation. So I'll just share the iterative version, very quick one. So
Yeah, yes.
okay, sorry, the wrong one. Okay, give me a second. Combination sum to count number. Okay. Okay, so this is the iterative way. So initially answer will be 10. Okay, so if your n is 0, return 1. Answer 10 and follow these things. Okay, so I'm setting t equals 9, and then I'm actually running through this for loop from 0 to n minus 2. Okay, so first digit I'm taking care of here. So I'm actually starting from n equals 2, right? So in that case, I come here and just multiply 9 multiply each and every time by 9 minus I. Okay, and then keep on adding it to the answer, and then you return.
Yeah.
Okay, so the way Harshit was saying, exactly the way it's implemented here, and it's easy to follow also. Okay.
Yeah. So I found this was the explanation. I mean, what do you say? I mean, same. It's a, both are same only, right?
Yeah, yeah.
What we have
It's
10
slightly
power 9
different way to follow.
implement here. So we are just summing them up here. 10 9 into 9 9 plus it. So it's a recursive call.
Hmm. Yeah, very smartly done. Yeah.
Yeah. Okay. This one, okay. So next is like palindrome number, right?
Mm-hmm.
So we have to determine whether integer is palindrome or not. Could you solve it without converting integer to a string? Okay. And for negative number, it will return false. For positive, it will be true. I mean, if it is palindrome, and yeah, and this is not again a palindrome. It will never be 10 because this is 10. It will become 0 1. This is a 32-bit number you'll have.
So if we convert into string, is it going to be of a higher
It will
time
be
complexity? What is the reason they say don't convert into string?
the reason because it will be very easy to solve then, right? You just this logic you won't be using division and reversing the number. Simply you convert to string and check whether it's forward and reverse are equal or not. One line code it will be, right?
Yeah, we
In
can solve
code.
it without reversing.
Mm-hmm.
Oh, without reversing how?
Like 2 raised by 32, like 2 raised by 30, like this is basically the integer range they have given. So we have maximum of 10 digits. We can store the digits in an array. Like we will create a first the 10-digit array, and we will create a variable size, and we will see like how many number of digits it has.
Can you annotate like I can?
No, he's saying that you take the number, whatever the text is, right? And then you
Mhm.
create an array for each and every digit. Okay. And so now you have digits separated. Okay. And then you
Oh,
compare them, right? You can use either a two-pointer approach, left, right. Okay.
Yeah, like yeah, the that way only. Like
Yeah.
maybe it is little complex, but in this way I thought.
No, it's not complex. It's good actually. Yeah. That is also good approach. Right. Only thing is if it's a negative number, you just, compare if
check
it
the
is
line
less
code
than, yeah,
probably.
initially itself, you stop. So that is one way of doing it for sure. Absolutely.
Only
Second would
that.
be like they are specifically said don't use a string. So I was just trying to understand why they said that. But I think what Shashank said is fine. It will be very easy to implement. Okay. And there
Yeah.
won't be more challenges. But still, the time complexity will be slightly more, right? In that case, or no? Maybe it will
Yeah,
be same. Yeah.
two passes, right? We are doing two passes.
But if we actually convert into string itself will be one pass and then comparing will be a two pass. Okay.
Yeah, similarly
Uh,
with what Hello said, same thing. We'll be doing it in two passes.
Yeah, for that
uh,
also we'll need to have two
so
passes.
I tried both ways. Like I tried with in Java, like string dot value of is taking more time as compared to the other one,
Hmm. Okay.
What
and
should take?
there will be there will be less overhead in case of if we use the simple array, like because we are not using objects.
Mm-hmm. Yeah.
Like if we are using simple character array, so character array is simply a primitive data type. So as this is as that as character array is of primitive data type, it will not have extra overhead. But in case when we are using string object, it has extra overhead.
Mm, okay, so you're saying space, right? Space, yeah, anyway, space is going to be there. So I think what Shashank is
Is
coming
there
to,
any other trick in that? I mean, to me, that converting to a string or extracting the digit, putting in an array is the same thing.
right, right. At least the
So,
space is going to be the same.
is there
So
any other trick, some mathematical trick or some bit manipulation?
bit manipulation. Huh.
I'm just think out loud. I'm not sure, I mean,
Yeah.
whether it works or not, or anyone actually explore the discussion section.
Yeah, I'm not able to see a one pass solution. Like I'm also trying to figure out.
Yeah, one pass solution should be fine, right? If the way Shashank is doing,
Yeah, reversing. I mean,
that is
I'm
itself
taking.
one pass, right? So
Yeah.
in fact, it is doing only halfway,
This
half pass.
the way Shashank is, this is an O1 solution, isn't it? Or,
Not O1 actually.
oh,
It at
no,
least
we
goes
are
to
actually
Oh,
getting
login. It will be login.
login. Yeah, yeah, yeah.
not
Because
log, and it will
it's,
be n by 2.
yeah.
Okay, sorry, it will be. Yeah, but yeah, it is. It will be considered O of n, right? Yeah.
Yeah.
Login base 10 it will be, right?
I'm sorry.
No, login base 10 I'm saying.
Log
No,
n
no, no,
base.
it won't because last step will take O of n, right, for comparing.
Yeah. So
No,
if you
but
have
this is
1, 2, 2,
also
1.
two pass only, right? First you form your number, reverse number,
Then you check.
in the loop, and then you compare. So
No, 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 no,
comparison.
no, no. You actually can do it slightly different. When you are in this while loop, you can say if your number is greater than your reverse number, then only you go. So as soon as your number becomes lesser than your rev, you can exit and then you can just compare the results. There can be some slight optimizations. He's actually going all the way down, which is not required.
Hmm.
Okay, okay, I got it. So you're saying that only form the second half,
Yeah,
right?
only one half. Yeah,
Okay.
yeah,
That's a nice more optimization.
Yeah.
yeah.
Here
That,
we're
that's
going
fine.
all the way down. So basically, we're going all the way down to 0 and then checking if reverse is equals to the original number.
Correct. Yeah.
Yeah.
Okay.
Interviewer can push you to that level n by 2.
Yeah.
Yeah, but that will be always because it's very simple problem. Usually for this, we will always go right. Only the condition what we have to check is the negative number and the 10. If you see the 10 case, that is the only thing you have to check before even going inside this loop. That is very important.
The 10th case I didn't check here.
You didn't check because you are actually going all the way down, right? So if you want
Okay.
to do it the halfway comparison, for that you'll have to check the 10 and the this one negative number. So if you can check those two conditions, then you can do that half yeah, splitting like that. Yeah.
10 condition, Santosh.
Yeah, if you see 10, so you can very well say if my number is having a 0 at the very LSB, okay, and the LSD, so then I cannot form a palindrome, right? Because you won't have a zeros,
Okay, okay.
yeah, starting zeros, right? So that condition you actually completely eliminate here, and for the negative, then otherwise you can actually do that half pass.
Yeah. Right.
Just a question. Like it will be maximum like 10, right? Like for this case, like in case of integer number, like we have a maximum of 10 iterations, right? So can't we
Mm,
consider it as O1?
10 iterations, why?
Because the maximum number of digits will always be 10.
No, why is that?
It's a 32-bit integer, right?
No, no, no. He's right, I think. Yeah.
I
Yeah,
didn't like.
10 digits is saying, right? So maximum will be if 2 raised to 32 also whatever we get,
10
you
to the
know,
power 9 something.
yeah. Yeah, that
Okay.
is there, but in that case they will say your n itself is 10, right? So O of n. So it will be a single pass in that case. You can say it's a constant, but yeah.
But
But the time complexity, if you try to evaluate, is going to be O of n and n will be the number of digits. And you can always argue it's going to be a yeah constant, yeah. But still you are going a while loop, so you are still
Okay.
going in that while loop, right? Yeah. And how much you can actually
Yeah, yeah, I
optimize,
agree with
that's
your
always
point.
good. Yeah. Yeah, yeah. That is also fair argument. Yeah. Okay. So this is done, right? Okay.
yeah.
Anything else?